Alright, welcome to Organic Chemistry. This will be theory for IGCSE and O levels. Right, so let's actually begin with an introduction that no one asked for. This is completely useless, but it'll let us set a proper baseline for what organic chemistry is actually about. Right, organic chemistry is simply the study of organic compounds. What are organic compounds, you might ask? I can define organic compounds as being compounds that contain carbon. Now, that is both true to its meaning and also is not the entire meaning. So, a better way I would like to explain is that organic compounds are compounds that contain carbon chains. Contain carbon chains, almost like a carbon skeleton or a carbon backbone. So because whenever we say a compound containing carbon, things like carbon dioxide, carbon monoxide, and other things, they also come to mind. These are not really organic compounds. We don't consider them as being organic compounds. All the compounds that you'll be studying in the further areas of this course would be compounds that have a carbon backbone. So, organic compounds. Now, before we actually get to the first subtopic of this, I would like to introduce a term that will be very important in the future. We will be talking about what a hydrocarbon is. Now, just by looking at the name, we can see there's some form of hydrogen involvement and some form of carbon involvement. So, there's nothing complicated here. A hydrocarbon is simply a compound that contains carbon and hydrogen. Okay, hold on. Containing carbon and hydrogen. But there's a twist. It should contain only carbon and hydrogen. This is absolutely important. This singular word will cost you an entire mark if you don't write it down. Questions will ask you straightforwardly, define a hydrocarbon. What is a hydrocarbon? What constituents does a hydrocarbon contain? You have to make sure that you mention that a hydrocarbon contains only carbon and hydrogen. Now, trust me, going forward in this course, you will know about hydrocarbons like the back of your hand. For now, this is enough. If something contains only carbon and hydrogen, that's a hydrocarbon. I'll just give you an example as well. C2H4. Is this a hydrocarbon? Let's check with the criteria. Does it only contain carbon and hydrogen? Yes, therefore it is. What about this? C2H5OH. Does it only contain carbon and hydrogen? I mean, it most certainly does contain carbon and hydrogen, yes, but apart from that, it contains oxygen as well. So this is not considered as being a hydrocarbon. That distinction is extremely important. Right, let me pick a pretty orange color. I mean, this is not really orange, but that's a nice color. Okay, right. So now we'll get to the first part of this particular introduction. Actually, I'll use this green to bring up that subtopic. So the first subtopic that we'll be talking about is we'll be discussing formulae. What is formulae? Formulae is simply the plural of formula. Formulas, okay? And then we'll be talking about functional groups. We'll be talking about functional groups and terminology. Now, don't worry, that's not something that's hard. Terminology is simply the extended word for terms. So, in organic chemistry, apart from physical and inorganic chemistry, we have certain specific terms that we use. We'll simply be talking about those terms, that's all. Okay, let me focus this like this. All right, okay. when it comes to, now I'll be using my color. This is a nice color. We have to know about specifically three types of formulae. Three types of formulae. Now, there's more than three types of formulae in the wide multiverse of organic chemistry, if you will. But for IGCSE and the ordinary levels, you only have to know about three main types. I will touch up on a fourth type as well, but you just have to know about three main types. I will outline all of this. So all of this that I am about to explain in this particular session would be the basics of organic chemistry. Without catching on to these basics, it's going to be very hard to hold on to alkanes, alkenes, alcohols, carboxylic acids, and esters, and all that stuff. So make sure you practice, make sure you go through all of this. Right, so the first type of formula that you should know is something known as a general formula. What do you call that? This is known as a general formula. General formulas typically look something like this. CnH2n plus 2. Don't freak out. So there's n's and 2n's and addition and blah blah blah. We don't have to worry about any of those things. Just so you know, this is what a general formula looks like. And now exactly what does a general formula do? How does it help? When it comes to a general formula would help you form any member, any member of a homologous series. Any member of a homologous series. Now, if none of that makes sense, that is completely fine. All of that will make sense. For now, if it does not, that's completely fine. If you're taking down a note, you just include that in your note. Okay? The second type of formula that you have to know is something known as a displayed formula. And this is a very special and important one. So talking about something known as a displayed formula. A displayed formula looks a bit like this. See, I am pretty sure you have seen these formulas lying around. That is what you call a displayed formula. Can you see that everything is displayed? What do I mean by everything? By everything, I mean we are clearly showing all the atoms. We are clearly showing that hydrogen is here, carbon is here, carbon is here, here. And also we are showing the bonds. All atoms are shown and all the bonds are shown as well. So this is an alkane, C2H36. We'll talk about those things later. All you have to know is if everything is spread out like this, we call that a displayed formula. Everything is displayed, it's very simple. Okay, now you won't really be asked what type of formula, define the three types of formula, none of that stuff. There's ways in which you should use this information. I'll tell you how exactly you should do it. Okay, something important about displayed formulas I should tell you. Now, okay, all of you, everyone, that is, I'm pretty sure everyone who wants to learn from this level are rookies to organic chemistry. You're starting from the basics when it comes to organic chemistry, right? Since you're a beginner, this is the type of formulae I want you to use the most. Okay. There are certain different types of formulas that you can employ. Some are easy, some are hard, but no matter what, no matter what other types of formulas you think you should be using, as a beginner, I want you to focus on displayed formulas and displayed formulas only. Okay, that's what I want you to do. And then the third and final for your syllabus type of formulae that you should know is something known as a structural formula. Structural formulas are tricky when you're starting off. They're not hard, okay? They're not hard. They're tricky when you're starting. Okay? Now, if I take this compound, I'm just going to draw the structural formula of this compound. Okay, take a careful look. I'm just going to split this molecule like this here. And I'm going to read the molecule from left to right. Okay, just to confirm, I'm reading it from left to right. So when I'm reading it from left to right, from this side I can see I have a CH3. So I'm writing that down like this. And on the right hand of my dotted dashed line, I have another CH3. So I'm writing it down like this. That is your structural formula. It's just giving you the structure. Do you see? No clear outline of atoms and where they are, no clear outline of all the bonds, nothing. Okay? That is why structural formulas are tricky. It gives you so little information. But do you see displayed formulas? They give you so much information. That's the thing. Right, so when it comes to structural formulas, I'll just put a command, give you another one. CH2 double bond CH2. And if all of this seems daunting, don't worry. We're just brushing up on the basics. When we get to specifically alkanes, alkenes, and all that stuff, everything will make sense. Okay, right. So let's just write down what are the features of a structural formula. Do you see? Most bonds. So most bonds are actually removed. So we can say most bonds are omitted. Okay, but things like double or triple bonds are specifically shown. So if your compound has a double bond or a triple bond, the triple bond looks like this, you have to make sure you're showing. So no single bond is shown, do you see? So between the carbon and the hydrogen, there's a single bond, but we're not showing any of that. Okay, double or triple bonds are specifically going to be shown. Those are the three main types of formulae you should know. Three main types of formulae that you should know. And then just 4 with an asterisk is the molecular formula of something. It's the molecular formula. Something like if I have a compound, I'll just call it C2H6. No, actually, yeah, C2H6. So that's the molecule, and that's the molecular formula. It's literally like saying the molecular formula of carbon dioxide is CO2. The same thing, it's just the molecular formula, nothing fancy. Okay. Something I wanted to talk about was, I'm not including this in your syllabus, but it's a noteworthy mention, so I'm just mentioning it. That's something very funky known as a skeletal formula. This was previously called bond line formula. Now this is known as skeletal formula. Let me show you a skeletal formula. Boom. That's a skeletal formula. Okay. Don't include this in your syllabus. There's no inclusion of this in your syllabus, but it's good to know because in AS and A2 levels, you will most certainly have this. Just a recap, general formula displayed, and then you have structural formula. Molecular formula just as a fourth type. These are the three main types that you have to know. Nothing beyond that, just a molecular formula. And then you have skeletal formula. Skeletal formulas are so fun once you understand it. You can save so much time using skeletal formulas, but to understand them, it's gonna take a lot of practice. Yeah, that's the thing. Right. Those are the three basic types of formulae. Now, I'm going to talk about something, a concept known as isomers. Bear in mind, this is not isotopes, okay? Isotopes is physical chemistry. Those are compounds with the same proton number but different neutron numbers. We're not talking about isotopes, okay? A common confusion in organic chemistry beginners is that they confuse isotopes and isomers. They're two different things, okay? Now I'll start with a formal definition for what an isomer is, then I will illustrate what I mean by this definition. That way you'll catch on to isomers. Going forward, we have more complex problems and aspects of problems where we have to name isomers, identify isomers of certain compounds. So I will also get to those things later. For now, this is a basic introduction to isomers. So I can tell you that isomers are compounds with, pay very careful attention, they have the same molecular formula. They have the same molecular formula. Okay, they have the same molecular formula, but they have different structures. Read through that again. They have the same molecular formula, but different structures. How is that possible? It's impossible to explain that to you without a diagram. So a diagram is what I will use. Okay, for example, let's say I have compound A. I will draw something like this. 1, 2, 3, let's stop at 4, and then all hydrogens. Um, Random question, but what type of formula am I drawing? I'm drawing a displayed formula. Everything is displayed. Is this the type of formula that you should use as a beginner? Absolutely right. Let's write down the molecular formula of this. So we have 4 carbons. And how many hydrogens? 1, 2, 3, 4, 5, 6, 7, 8. I'm literally counting them, okay? 4 carbons and then 4, 8, 9, 10 hydrogens. C4H10. I'm drawing a line like this, and on the right hand side I will write down the structural formula. Let's move that to the side. I'll write down the structural formula. I'm just going to break down this molecule like this. So this is basically how you draw the structural formula of anything. So just draw some dotted lines. As you move along, as you get more practice in drawing structural formulas, this will not be necessary. Okay, you won't have to divide and conquer and nothing like that. This is just for you to practice. Work from left to right of the molecule. What do you find first? First, I get this CH3 segment. So I'm writing that down. Then afterwards, what do I get? What is here? That is a CH2 segment. CH2 segment. Then again, so that's done, that's done. So also mark those things. That's done, that's done. What do I get again? What's this? That's another CH2. That's done. What am I finally left with? There's a CH3. There's a CH3. This is the displayed formula of compound A, molecular formula, and this is the structural formula. I think we should write that down. D for displayed formula. This is the molecular formula, and I have also written down the structural formula like this. Okay, now a line goes through, and now I'll write down something known as compound B. And compound B will have a structure that goes like this. CH3, CH3. Don't worry if it seems very confusing, it's not. The only thing is that here we have something known as a branch. We will talk about branches and naming and all of that stuff later. Here we just have a branch. That's the only distinction that you have to notice here. Okay. So now I'm gonna write down the molecular formula. How do you write down the molecular formula? You just count everything. 1, 2, 3, 4. So 4 carbons. How many hydrogens? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Did you notice something? It's the exact same. C4H10, C4H10. They have the same molecular formula. So just let me write down the structural formula as well. So I'll just divide the compound like this just for clarity. Work from the left. First I meet a CH3. I will tick that part and write it down, CH3. And then this is where it gets tricky when writing structural formulas. I will do a separate worksheet on structural formulas and displayed formulas and how to convert between them. For now, this is the basic idea. So CH3, now here we have, so we're coming from this side. First of all, we have this CH. So let's write that down like usual. We have the CH. Okay, we have the CH. Now that part is done. I'll put a green tick on that. Now connected to that is this branch of CH3. When we represent branches in structural formulas, we use brackets. There's a branch of CH3, a branch of CH3. That's all. A branch of CH3. And then that all of this is done, so I can move on to the right side. What do you have? What do I have again? Another CH3. Simple. So you cancel that out. And that is your structural formula. I'll also mark those things down. Displayed, molecular, and a structural formula. Let's assess this situation. We have the same molecular formula, but their structures are different. You see, this is a linear molecule. This is a branched molecule. And because of their structures being different, obviously their structural formulae are going to be different. So once again, what has happened? These are compounds that have the same molecular formula, but they have different structures. Linear molecule, branched molecule. That is the basic idea behind isomers. That's what we call an isomer. More on all these formulas and isomers will be done. Now let me tell you what we mean by a functional group. What is a functional group? Simply put, a functional group is an atom. So it can be a single atom or it can be a group of atoms. A single atom or a group of atoms that determine the chemical properties of a compound. Whatever compound they are part of, they determine the chemical properties of that compound. This will become more abundant when we get to homologous series. For now, all you have to know is that a functional group is that. So what exactly does a functional group look like? So we have OH functional groups, we have C double bond OH functional groups, things like that. More on those later. Adding to our terminology segment, so we talked about, so terminology means terms. We talked about hydrocarbon and hydrocarbons, what it means, and I would like to introduce the idea of a saturated molecule. A saturated molecule and the opposite of that, which is an unsaturated molecule. So what exactly is a saturated molecule? A saturated molecule is the where all the carbon-carbon bonds are, whoops, let me get rid of that. Carbon-carbon bonds are single bonds. Okay, so let me represent a saturated molecule, carbon, 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 and then we have hydrogen. Do you see all the bonds in between carbons are actually single bonds. In that way, we call this molecule a saturated molecule. Saturated means completely full. You can't put anything in. If I wanted to add an extra hydrogen, it's not possible. So then on the other hand, what exactly is an unsaturated molecule? What is an unsaturated molecule? This is where, so any compound where, not all, but one or more carbon-carbon bonds are double bonds. Are double bonds. Hmm. Let me also show you an unsaturated molecule then. So here, carbon-carbon has a double bond. Because of that, only 4 hydrogens can fit into the molecule. There's a reason for that. When we talk about alkenes, specifically, I'll get to the nitty-gritty of the reason. For now, all you have to know is that this is a saturated molecule, all single bonds, nothing can be filled. This is an unsaturated molecule. The other line those saturated, unsaturated, saturated, and then you have unsaturated. Here we have at least one double bond. Here all we have single bonds. Here we have at least one double bond. Those are the basic things you need to know for the starting bit of organic chemistry.